So, welcome people. I guess someone will join later, maybe. And yeah, it's great. Do you hear me good? Well, yeah, okay, perfect. So I'm very happy after a few years of research and prototyping, and we're here. And as I wrote in the post, I think it's a good moment that the knowledge around this topic is mature enough to be shared, and the project can really be like a concrete thing that we all together push ahead. So then yeah, I'll start. I already prepared something like not a presentation, but at least a sketch stuff, so to help explaining the topic. I'll share my screen, I guess, right? Share screen. No. How do we do that? Need to grab me the. I have co-host. You just need to
allow participants to share screen.
No, select my name.
Multiple participants can share. All participants. Now you can.
Screen. Share. Cool. So do you see my screen? Yeah, perfect. Yeah, Kairos. If I need to describe it, is a framework for data control and composition, and that's why I always say it's more than a timeline. So, say that. Maybe you can go full screen. It's already like 5 years at least that I'm researching the topic concretely. So, and during this journey, in which I was here in Berlin, hosted by the guys themselves, to get here, basically I developed many libraries, like Elementa is one of them. And so but the point of this research was to get to the essence of the problem and to really find the most meaningful solutions and more generic solution. And that's why, yeah, it basically grow, and it's very exciting, I would say. So Kairos is composed. It's Kairos in its entire. It's composed by different libraries at this point. So, and these are the libraries. There's Alchemix, which is a set of functionalities that allow you to synthesize values. That could be like lerping, interpolating between values, or blending them together, composing, which is a combination of the two. So it's a library that allows you to just manipulate values, and we will see how this fits into the big picture. Layer X is introduce a new concept, which is the layer, and all the functionality to operate with it. And then Kairos, in the end, is the uppermost layer, the library that basically makes use of the other tools and introduce another perspective that is meaningful to then do what we need, which is controlling systems. So yeah, this is like the structure of the libraries, and in this onion shape, so that layer X use Alchemix and Kairos use the other two. And we will go into details. So, but first, what's the problem? No, what we want to do really? I think it's worth, instead of starting to talk, okay, we need a timeline, we need keyframes. I really need to communicate the reasons behind this research. Otherwise, we miss the point. So I started because I tried to do this project already in beta years ago, and it wasn't possible. And because since the beginning, I come from this. I'm a sound visual artist, so I do a lot of real-time performances, and I really work in the performative environment, and I always had the need to timeline things, but at the same time, using real-time inputs like audio analysis or motion capture data, and combining the two aspects always have been almost contradicting in using old paradigms. Like in a timeline, you can set keyframes, but once you set a keyframe, that's the value. And maybe I don't want to do that. I want to have my value that will be generated during a live show, but still I want to organize over time when things happen. So the old timeline school tool was already not enough. So going deeper, then let's go to the root of the problem, which is, okay, what do we want to do? We want to control our data. No, let's say we have an application which is a sound visual tool, that a music visualization tool, and then we want to control the aspect, all the parameters of this application, and maybe defining, okay, that we want to timeline some of them so that they change over time during our live shows, but maybe some of them we want to directly write values, like define these parameters values. I don't know, storing presets on our hard drive, or writing a constant in our code, or receiving it from a sensor via a network. So these are direct ways to assign a value to a parameter in a system. There are other values, other way to control these parameters. A very common one is just to have a bunch of possible states of this value, and then combine them together in some way to generate the final one. And this is what a timeline does. No, we define some keyframes which are states, no, of our value, and then we create this function that can be sampled to generate the output value that we are really using. So treating collection of values. So this is just to say that there are many ways in which we want to control a system. So yeah, then a very important aspect is that we want to manipulate values, especially in this case, this second case in which we want to control, generate, synthesize values from multiple other values. We need a library that allows us to manipulate and generate values. And this is what Alchemix do. It does. So I didn't update any. I don't think that they are updated in GitHub still. This is something that we are going to do here at the camp. Before, the library was called the LERPX. Now I changed it because it makes more sense. And this library is just dedicated to value synthesis, which means, okay, give me some values and I will do something with it. And it's very, it's like very simple, no, to understand. It's like having a plus, no? You just give two numbers, two values, and you get another one. It's like pure functional in this way. And this Alchemix offers advanced nodes to operate on the value and synthesize values. Like, for example, it comes with some, an interpolate node that allows you to interpolate between two values using advanced ways to interpolate between them, and considering also for example, the spread count, or it's just, instead of having a simple lerp between two numbers, it push to the limits this interpolation concept. So you can feed any sort of type, any sort of numbers, and it will make an interpolation using these techniques that are available. This is one of them. There is a blend node, which allows you to blend two numbers using some common techniques that we know from Photoshop, they get blended together. And then we have a compose node, this one, which takes two values and apply this composition, which if you go into details, you realize that it's just a combination of a blending and interpolation, but introducing this transparency concept on top. So it still is like a wrapping of the other two functionalities. But these are very convenient nodes, and that you can already find. And so, if you there's the nugget. Actually, it just expired the key, but I will publish it again. So the library consists of this very basic nodes that I described, and as you see, just interpolate between numbers, between spreads. So you can have past collections of numbers, and the node will interpolate between them, taking into account the different length of these arrays, these collections. And I can apply this to spread of spreads. So it's a complex machinery under the hood that takes care of this. Same is for blending, as you see, this is the shot that we saw. So different methods. You can pass any type, as you see here. And composition is the other one, yeah. So you can, these are help patches that comes with the nugget, so with the NuGet, so you can have a look when you install it. And same principle, though, it takes care of interpolating and properly the spread count, which is the number of elements into every array. So, but still, to go back to the essence of this, that this is just manipulating values, no? Get rid of this. Leave it. Okay, so the next library that is a key element in Kairos is this layer X. And layer, this library introduced the concept of a layer. And the layer is, so to say, the medium is it's like the space itself where you place objects that you can inspect, you can sample, you can ask a value to. So there are different aspects into this layer library and this layer concept. The first and basic one is that you can sample the layer to get and you get a value back, like you see here. Let me just open the patch. So it's, I think it's this one, right? Yeah. So this is a layer, for example, a region implementation. So a layer, this object, it's something that I can sample with a sampling position, and I get an output value. Okay, so it's like a function. okay, that I can give an input, saying, okay, in this position, what's your value? And it just returns a value. It's a function in its essence. So this is the first important aspect. And layer has dimensionality, which determines how we sample it. Okay. In this case, we have a layer 1D, which means that you can think about it as a one-dimensional space, like a track of a timeline, for example. No? So how do you ask a value to a timeline track? You say, okay, give me the value into this time position. So the sampling position is the coordinate into this 1D space. You give that coordinate, which is a float 64, and this layer returns, returns a value, which can be any value. Now, in this case, the type of this layer is a float, but we can have layers of any type. So this is the same. Layer X comes with a set of nodes already to, for example, have a value layer 1D, which is exactly this patch here, conveniently wrapped into this node. It's just a layer that you can pass a value, and that's what you will get sampled when someone asks, when someone sampled. But still, it's a layer 1D. But if you think about it, if we really generalize and think, okay, it's just a medium, the layer, we can then think, okay, we can have so many other ways, so many other spaces that we can think as medium. We are used to live in a four-dimensional space and medium, which is 3 coordinates system like X, Y, Z, and then we have time. So, but on a sheet of paper, we have 2 dimensions, no? X, Y. So, and the 2D layer is another example of that. So if I, there are a few examples here, like compositor. Yeah, I still need to, what is it? I don't know. Yeah, I didn't check these patches. They're probably broken. Since I was working till last minute yesterday, I didn't check this. What is that? Anyway, so you can imagine that a layer 2D, let's just do it. This is more complex. Let's do it later. But this one, okay, let's say if I have a layer 2D, like a value layer 2D, we have a sample layer 2D, yes. This is something that I can sample, right? But it's a 2D layer. So this is the value that I will get when I sample it, okay? And the sample, the sampler basically that sampled this, still need to, oh, anyway. The sampler that samples this layer will need to provide a 2D coordinate, no? Saying, okay, you are a 2D layer, so we can already imagine like a 2D space, like a plane. And so if I want to sample that space, I need to give in 2 coordinates. So the sampler say, okay, give me the value that I would have in this coordinate of your space, which is 2D. And this is what this layer 2D does. If I, instead of that, I implement layer 2. Yeah, layer 2D region. You see, this is the region version of the layer, so that we can patch in what happens inside the layer. So you see, this is something that we need to fix this week. inside you see that. So this is the background. We will talk about it. High background function. This is the vector, the sampling position, and this is alpha function. We'll talk about. But the core thing is that okay, someone down there is asking for the value in this position. Okay, and this is exactly what comes here. No, this is the sampling position. Then it's up to the layer to do something and return a value here. Okay. So let's say that we can, for example, have a, I don't know, we take this sampling position that they're asking for, and we implement a function there, no? That returns something. Obviously, it needs to go and shift the something like that. So now you see that depending, the y is not considered. We build a little patch here to do something, no? So as you see that the output here, depending on where we are, depending on where we sample, will change because internally the layer will use the sampling coordinate to generate a different value. Okay. But this guy doesn't know anything. He just say, okay, I just want to have a value in the, with this in this coordinate, and then it just returns to the. It's just up to the layer up there to do something with that. And as we say, this could even be just a constant value, no? Like this. In that case, no matter what we do here with this would be a constant value that will be everywhere in the space, because no matter which coordinate we asked for, we always get that. And this is exactly the value layer today. Internally, it does that. It just simply pass the value as it is without considering any sampling position. We will go back to it. Okay, everything clear so far? Good. So an important aspect of that is the layer. It's just it's a patch. Everything can be a layer. You just need to, even a custom data type just needs to implement I layer 1D, and then it can be sampled. No? So, but these are just a set of convenient nodes that already comes with the library to simplify also explaining. A key element is that whatever is inside here, whatever happens, whatever we patch, this get evaluated just when we sample, because this is literally a function, an operation that gets called, you know, like, which is sample operation. So everything get implemented inside the layer. This sample operation will get evaluated when someone asked for it. So imagine like this. That's why you can, for example, have very heavy algorithms or entire massive patches inside a layer, and they will be computed and used only when it's necessary. No, when imagine this is a keyframe in your timeline. Only when you're getting there, when you start to sample, to interpolate to it, and when you're on the value, only then this machinery gets computed. So it can be used in an efficient way. No? But also there are different aspects that we need to consider. If you put something inside, like an LFO in this case, is inside, right? And we are sampling this layer. The switch is at 0, so we take this one. And we are getting the value out of that. If I turn to the other one, in this case, the LFO is outside, right? Okay, it's outside, and we simply pass the value as it is. As you noticed, this LFO here simply stopped because it was inside, no? So it gets computed just when it's inside. If I go back, you see that as soon as I switch back to it, it starts computing again. So we need to keep in mind that there's a difference between the two scenarios, which could be meaningful in different ways, no? Then just this was just a very basic example, but you can imagine building an entire library of nodes and creating your own layers using this concept. But I don't know, having an OSC controller layer where you just, this is a node that you plug a MIDI channel and you choose the controller, and then this is something that you can ask for a value, for example, and internally we'll just check. This is a very stupid example, but just to say that if you can build on top of this principle any sort of library. Another very important aspect of this layering is that since they are like pure functions, so to say, you can have you can nest one inside the other, no? And this means that you can build a graph of layers calling each other, and obviously this is a very basic tree with one branch. But then, as we think of a timeline, for example, a timeline track, in that case, there is a layer which is the interpolator that deals with many elements like keyframes, and it can intelligently choose the one that they are relevant and just sample those and learn between them. Okay, so in that case, it's a more complex graph with many leaves, which are the keyframes, and then we are activating meaningfully certain parts of this graph. And keep in mind that each one of them can continue to another graph, to another timeline, to another, so the graph can be very complex. So this is a key element also of the layer that allows you to then extend on top this calls from downstream and then build complex graphs. This is a very basic example, no? Of so this part here is a set of nodes that comes with a library itself, and I basically repatched a simpler version, but just that the essence is similar, so to say, where I have two layers and I have this other layer that internally what it does, when someone calls, when someone samples it, it takes this coordinate and use it to interpolate between other two layers, which will be the keyframes, so to say, no? And this is exactly what happens in some more advanced functionalities, like the interpolator 1D. It takes a collection of interpolator shapes. It can be a keyframe or a clip, whatever, and interpolate between them. And a keyframe is nothing more than the shape in which a layer embodies into a domain. Because once we, let's say that we have an interpolator, which is like a timeline track, and we say this is the space, 1D, one-dimensional space, and in there we can have bodies, we can have items. And what kind of items we can have in that one-dimensional space? We can have a keyframe that we are used to, we can have a clip. Okay, those are, so to say, the shapes, the objects that we can put in that space, we can manipulate, okay, and that we can adjust and control in place, so that we control a narrative. We can define a narrative through this one-dimensional space. Then they are just pointers, so to say. No, when it's time to ask for a value, and we get onto a clip, that clip is just how an upstream layer embodies into this context. No, it's like, okay, I want to have the spirit of Jorg. Okay, if I want to relate to it, I can relate to it because he embodies into this shape, to this configuration in reality. Otherwise, I couldn't interface, I couldn't even see. No, just the layer is the spirit of Jorg. No, and the clip is the body and all the aspects. which is embodied into this context, which is the interpolator. So the layer is just an abstract, is something that I can ask for an essence, for something, for a value. Huh? But in order to the way I access this source depends on the context. If I'm in 1D space, I can ask just into this one-dimensional space and through these embodiments, like a keyframe or a clip. If I'm in a 2D space, well, imagine what you can do with on a sheet of paper. I can draw shapes. Huh? That's another way. For example, I can have a shape, circle, square, like a rectangle or triangle, and each one of them can be like the way a layer embodies into this space. So then in that space, I can walk around in a 2D space and I can stumble upon a shape and say, okay, I want to have the value here. And that shape will obviously connect me to the source of the value, right? So the domain is, then it's interesting because you start thinking, okay, then one topic is the values, and one topic is how they embody it. And and I can have the same set of values embodying in different ways, in different contexts, like a 2D interpolator or like a compositor in a 2D space where I can blend on top shapes. It's really up to the building these spaces to then define what do we do with those essences, with those values and layers. So is it clear this?
Are you taking questions or?
Are
you taking questions or?
Yes.
You're asking the layer for a position. I get that.
I asking a value.
Yeah.
And I give a position.
You give it And I'm missing kind of how does the layer know its dimensions?
The layer doesn't have any dimension.
So
okay, the shape. What is the dimension? What is the dimension of your body?
The space, like where it starts and ends.
Yeah, but these dimensions are your shape, your body, no?
Mm-hmm. And where is that here?
Here there is no, okay, in the sense that I give from granted that I sample from 0 to 1 here, and I simply interpolate between them. So if you
sample position is not necessarily between 0 and 1.
No. This can have any number. No, it's just this was just a simpler representation.
Yeah.
Okay,
You just
there is no, there are no bodies here. There are no shapes.
Yeah.
It's pure values. If I go to 10, okay, it's up to the learner. What happens if I put a 10 here? I don't know. It will just stick to the upper one, or it will interpolate in this case and continue this curve going up. But so that's why we introduce more advanced concepts, and that's why I label this way. When we're here, we are into another. We introduce another layer of concepts, which is okay. We want to operate into this space, and we want to deal with objects because we want to define their size and their location, so that we can meaningfully say, okay, I'm sampling from the beginning of the clip and give me the value there. And that's why there is this distinction between the layer and the keyframe. Keyframe is really the shape. It's just saying, okay, there is a layer up there, which is something that I can sample, but by itself, it doesn't have the concept of being a body or having boundaries. It's just, I would say, it's almost like it's just a space, right? You can imagine like this example, the window. Okay, we are inside here, and we want to see what's outside there. Okay, and the window is the frame that gives us shape somehow to our view, our vision over the outside, no? So the keyframe or the click there is what basically transport our view over this other space.
Yeah, but so I wasn't, like, the layer concept is part of the library, but this clip shape thing
It's
is
part of it.
Is okay, but you haven't mentioned that explicitly.
Yeah, I said that it is part, it comes with the library.
But can we also see that? How does a shape work?
So this is the library, okay? And the most generic interfaces are iLayer, and there are two versions because this is non-generic details. And as I mentioned at the beginning, we can have any sort of dimensionalities, no? Now 1, 2, we can have 3, 4, and dimension. It's just up to us to implement. So let's go into the 1D domain. So we have more specific interfaces that these functionalities will implement. iLayer 1D, which if we look at it, says, okay, sampling position is defined as float 64. Now we know we are in one-dimensional space, and you will need to give me a 1D coordinate to allow me to return a value. This is a 1D space. Yeah. So these are some basic functionalities. These are like the regions. This region here, for example, it's a very basic implementation. But then we have some more advanced functionalities, which is the interpolator that we used there. And you were asking, okay, what are the shapes? These are the shapes. So there's an interface, which is an interpolator 1D shape. And then there are two shapes, keyframe and clip. And then there is the interpolator. Okay.
Can we have a look at the interpolator shape interface? Just briefly.
Yes.
So here I have the bound min max.
This is the body, the characteristic of the body, which is okay. We are into this 1D space, and since you're a body there, at least the essential is you give me the min and the max, right? That's enough. And in the case of the keyframe, that would be the same, no? But still, that's enough to define, the nature of this body into the space.
But what if I want an infinite
Shape
domain? Yeah.
You can well, in that case, yeah, there is no. We could add like another shape,
Okay.
so to say, which is constant, it doesn't basically doesn't return. It's simply a constant value. It doesn't need the notion of bodies, no. And in that case, you don't even need an interpolator, no. If you want to have a constant, if you do that.
No, but I think
right.
you meant an infinite field of values.
Or
An
like
infinite noise field.
or just a form like a sine wave or something. Like it doesn't have a domain, or
Yeah,
maybe
like
with
this.
a max.
This is what I say. If you do like that, and you take what comes from here, we need a float 32. This is exactly that.
Okay, and here we're skipping the shape part, basically.
Yeah, we don't need any shape, no? We just need a pure function, so to say. And in this case, this layer does that, no? When we sample, like let's put a stopwatch node, which simply counts up. Okay. This number increase, so it just go, and this will return the result of the sine function. And there's no notion, there's no need, it's just a pure function. When we have an interpolator, here it's different because, okay, we want to have bodies here because we want to structure in a certain way the way we think of data. The thing that we have keyframe and clips is just an idea of how I want to access the values. I want to work with this abstraction, imagining that we have objects and thinking how they relate to each other. It's just an abstraction, just an imagination that we do over the values, right? Just this level of imagination, it's implemented using this interpolator concept and these shapes. So how does it work, the interpolator? It takes the shapes, a spread of interpolator 1D shape, and then collects the some min max, and then does some binary search to understand where it is between them, so that it can pick. Okay, I'm here. Just give me the previous one and the next one, because that's what I need to be able to interpolate between those. No? And then once I'm there, we will interpolate between them. We will sample the first, and then if we are inside, we just get keep the value as it is as the output. Or if we are in between, we sample also the other one, and we interpolate between them using some Alchemix interpolation tools. And that's why I was saying the other library that I was talking at the beginning is really powerful because it's very stupid. It's very simple, no? So it's like basic operations, but in a more extended way that we can use inside this other way of thinking. So then, and this is what the interpolator does. Just pick the shapes depending on their size, their location, and then produce a value out of those. And the interpolator itself is a layer on the again. And that's why I did that example there where I simply repatched something similar that doesn't really share, but still to really realize that this layer, the way it produces its value, it's just sampling some other value, some other layers and interpolating between them. No, just I introduced my own nature of my own functionality, which is lerping between something. But that something will come from someone else that I will ask to. In this case, these other two layers. So then it's really important then to understand that this separation, which is not present, for example, in the current Kairos NuGet, no, the old prototype that is available already. There it was blurry, this separation. It wasn't clear. There was a mixture of concepts, but now it's clear that this is just the body, how I can access into this context, how can I look there, and from there to there's a candle. So, and thanks to the fact that this body has these limits, I can look at it and see the nature of the candle, no? Just because it embodies in that way. It's a physical thing that I can relate to. It's the same. It's a keyframe is there. Okay, when I look at it, I see through it and I see the value that points to it. I see what comes through it when I ask for a value. Okay, so just all these shapes are windows over something else. And so you can start thinking, well, then since now we already separated these two topics, because we understand that they are really separated topics, the way they produce values and the way they embody, since there is distinction, then we can really get fancy and think, okay, then the way we want to control, it's a different thing from what we want to control, right? So timeline, it's, okay, we want to organize something into a one-dimensional space using these elements like keyframe and shapes, but then, and we want to interpolate between them. But let's talk about another example, like here. So this was like a timeline, that's that, no? This is the current timeline in Kairos. simply interpolation between value sources, so to say. Then what we have here, I just dropped some references. Like this is the Premiere timeline where I can put clips and they get blended on top of each other, no? Depending on and this is what it's implemented in Kairos as the interpolator, the compositor, which you can place clips and you can define the way they blend on top of each other. But then we can think of another way, like the matrix, the arrangement view in Ableton. It's just a matrix of values that I can organize into the space, and then I can, each column basically it's like a switch, no? It's a switcher that I can say when I play this clip, I switch to that one. No? It's like a switcher in vertical. It's just another way to access those data. I don't in this case I don't even need to interpolate between them. I just simply pass from one to the other. But you agree that I could take one of these clips and use it into another context. I could place it here in the timeline. In this context, it would basically get sampled and interpolated to another one. No? Or if I put it into this other context here, I can put it here, and when I sample over it, it would be blended and composed on top of something else, maybe, no? So it's just different ways to operate on values and make them relating to each other, to synthesize the final output that we are interested in.
I have a question.
Yeah.
Can we look at the patch you were showing us again? Okay, so we have, so these keyframes, they have shapes, they have boundaries, right? Minimum, maximum. But then on the sampling side, where you give it the sampling position.
Just to notice, this is not a layer.
Mhm.
This shape is just, well, yeah, I mean, the interface is probably a layer. No, not even, yeah, okay, I need to clean it a bit. So these shapes are just wrappers saying, okay, I'm a body, okay? So when you need something from me, I can point to a layer up there. So I can give you, okay, this is the layer that you're interested into. So you can sample this. They just hand over a layer. This is the thing. So, and this is what happens in the interpolator. You basically, you have a set of shapes there, and you pick the one that you're interested to, no? From the shapes, okay, the lower one is the index 1, and the upper one is, oh, because now we are outside. These are the lower and upper. And give me the shape, okay? And inside, when we sample, I don't know, we are sampling there, yeah, anyway. That basically allows me to sample the shape of string.
Okay, well, explain this basic example to me. So let's say I have a keyframe with boundaries, a normalized thing from -1 to 1, let's say, but the other keyframe goes from 0 to 1,000. Yeah.
Well, let's use a clip for that, no? Which is more like
Keyframe doesn't have the.
doesn't have
No, it's just a
Small
small
point in time.
one point in time. Doesn't have a many from two.
I see.
It's a shape with flat tape.
My confusion is when I sample this value that I pass in, what space is it in? Is 0.5 the middle of whatever the range of my clip is, or is it a literal 0.5 value? Like, am I explaining myself?
sorry, I missed at the beginning.
I'm thinking if you have two, again, what's the concept of keyframe? Shape. What are we calling these things?
Let me use a clip. Interpolate. Fantastic. It's more meaningful, I would say, because a clip I can say this is the position and this is the duration, like from 1 to 2. Okay. we can imagine, no? There's a keyframe at the beginning, and then at one, there's a clip, there is 1 second length. It's just shape there.
Okay, so let's say I have two clips, but they have different durations. Yeah,
Mhm,
when I sample downstream,
mhm.
this value that I'm giving the sampler, if I say, for example, 1, what does that mean?
This is the position that I have. Okay, I just want to have a value in that position. In this context, we are organizing space shapes into a space, right? So the interpolator will ask the coordinates of these shapes, no? I say that the keyframe now is at 0. So if I ask, what's your value at 0? Well, will be exactly on this keyframe.
Mhm.
When I go to 1, I will be at the beginning of this clip, because this clip is positioned at
Right.
1.
Okay.
And then we'll have a duration of 1. So when I go to 2, we'll be at the end of this clip, right? So this is why really the essence is just that there are shapes that I can position and I can compose, I can create this set of things so that I can structure how these values from upstream embody into this context. And
So now we have one keyframe that has a position of 0, right? That in this example.
Yeah.
Right? And then we have the other clip that has a position 1 and a duration of 2. So now it's clear we have a 0 and a 1 and a 2. We can use it as the sampling position, right? But what if you input the sampling position, something that is doesn't exist up there, like minus something or plus 2. And then is that depending on the interpolation mode, or how do you define that? What if it's 3 right now? What if it's minus 2 right now, for example?
the way it works, if you imagine like a timeline, if you put a keyframe here and keyframe there, outside the boundaries, you keep the values, the upper values and the lowest value.
Clipping.
It's just a clipping, no?
Clamp.
You just clamp to the most
Yeah.
the latest you have. Yeah,
Latest local
the
value.
available data.
Yeah,
So that's the way it works.
Okay, and what if in this way, example, they would overlap? How
Yeah,
is that treated? Because it's not a compositor.
Exactly,
It's
exactly.
just an interpolator, so how does that deal with overlap?
let's say we have 3 shapes. Okay, as you see now, I'm 1700. Let's put this up 3. Okay. So at that coordinates, you just clamp to the latest object value.
But here they don't overlap.
Here they don't overlap. Let's say that this is duration 2, and we put this at 2. Now they should overlap, right?
Mhm.
So if we go at 1, we get this value. As soon as we reach there 2, we switch to the other one.
Okay.
Because it's like this other
Last
clip,
one wins.
yeah,
like-
yeah, it just overrides that, you know?
The same.
And there is no space on interpolation because there's no space in between. So it's simply override, take over the other, no?
And this is based on
And
the order
this is-
they would put into the cons. Like if I
No.
flip them around.
Well, yeah.
Yeah,
That's
last one wins.
last one,
Yeah.
basically overrides, yeah, in that order. But keep in mind, this is just because we implement, because of the nature of this interpolator. Huh? The intention of this interpolator is just to interpolate between elements. We could implement a more sophisticated interpolator that says, okay, you can interpolate in the space in between. If they overlap the shape, we could even compose them on top of each other. But we could have this, we could implement this, no? It's not just about, okay, the nature of the values, no, those are just values, and we can define here a richer way to operate with them, no? Just another element that would have a different nature and will go, be more sophisticated. So in that case, like as you see here, the value layer, this layer, here I can by default, because with the library, the compositional aspect is part of it, in the essence. So I can already define how I want to compose this clip, no? On top of a background or something is below. So I can say, okay, I want to have this value and I want to have it like in additive mode. Now this is how I describe the composition, the compositing. And I can also say, okay, the alpha of this. Well, there are some concepts, very generic concepts that are introduced with the layer. Now, this interpolator is not really using this information because it's not operating, it's not implementing any composition, right, between these objects. But it could use this. And so imagine that if this clip is over this other one and it's in additive mode, we could potentially, okay, when we get there and they overlap, we take the second and we add to the value of the first, no? Just because we up there, okay, there's a knowledge about how I want to be composed on top of the other, no? So it would be up to us to make use of that. Yeah. Other questions?
Just one on my side. So the layers themselves have a description of how they want to be composed, but we also have nodes that allow composition on a separate level of abstraction. Yeah.
So I was wrong in the sense that we described how we want to compose them, okay? But the layers, they compose themselves. If I get inside this, when in fact, if you look at the function of like sample function, the signature of this function is that when I sample a layer, I ask, okay, give me a value in this position, and this is the background that you have. So this is what's below you. And this is the function, the alpha function of what's below you that comes there. So now it's up to you, please just give me the final value.
Compose yourself.
Compose yourself on top of what
already composed.
of what is below you. Okay, it's just you. It's tasked to compose itself on top, and you will see why.
So the background, Howard?
How do you provide this thing, the background? Maybe that's for later, I don't know.
Yeah, we will get to this. But like if you see inside the value layer, so this is a very basic implementation of the sampling function, but this doesn't compose itself. It is simply when you ask for a value, it simply returns that value. No matter what, we are not using this background, we are not using any alpha coming from downstream, we don't using anything of that. But the value layer, which is already richer, an implementation of it, you see, when we sample, this is the blue operation, when we sample, we get, we sample, so the alpha function that is coming from downstream, we sample the background. So we say, okay, let's get this background so that we can compose ourselves on top of this background. This compose node comes with Alchemix again. It's one of the functionality that given two values, you can compose the foreground on top of a background, giving some composition model that where you describe, okay, I want to have additive blending, and I want to, yeah.
But what's the alpha again? I get the first three, but the alpha?
Yeah, alpha is transparency.
Yeah,
Okay.
blending the actual value and the background.
It's basically, yeah, so we can, I didn't mark anyway. Oh, you did.
Probably.
So, yeah, so I don't know, I think this could help. We go back here, we say, what is compositing, no? In Alchemix, it's this, it's this entire thing, this object, no, this compose. You have a background, you have a foreground, and you pass a compositing model where you describe how you want to compose, and then you have an alpha. Inside, what happens really is that, okay, you have a background, you have a foreground, you blend the foreground on top of the background using the blending model. So let's say additive, okay, I generate, I take the background and add on top my foreground. And then the alpha is basically is telling how much I want this new value to be effective over the background, right? So I'm interpolating between the background and this value that I generated out of the blending, right?
Yeah.
So
With
that's
the
why
texture fix, we call that control.
in
Texture fix, we have the
control.
thing on every mixer, I think.
Okay, I kept somehow the paradigm of like a Photoshop layer, no?
Yeah.
Where you can then just have the transparency there. It's the art
Makes sense.
somehow.
When we talk about the background,
Yeah,
is this like who is before me in the cons in the patch we were looking at before, or is this background something else?
the weight, you mean here,
Yeah, so
the background, it's
Well, what overlaps in the same sampling position, no?
yes, so let's
It's not, so if you do compose these overlapping. That's my understanding. If you have a couple of overlapping,
so let's say that we have a compositor 1D, right?
the background is the.
The background are these other clips, right? But not even that. I'm saying that the background is really like something that comes from the beginning of everything. So if we go here, the very basics of it, when we sample, we already there. We say, okay, give me this value in this position, and this is my background. Like where is like the value of the space of this? If we say like, let's say, we say, this is my background, right?
It's like a constant value for the whole space. Is that it?
Yeah, exactly.
And then you build
And,
stuff on top of that.
but it's not constant, it could be calculated in real time also.
Well,
It's a,
where you are in a compositor node there, the background is like a function of all the clips that are below my clip here. So it's more complex. We will see.
I think background, if you call it maybe previous value.
It's a background. It's a background.
This
Uh,
notion of, yeah.
where I mean, take this because
I understand it, but it's not the most.
well, but you need to think, okay, where we,
intuitive word, I think, term to use.
well, if you think about it, okay, when we are here and we sample this layer, what's the background from this perspective of this layer? The background, we are there and we say, okay, what's the background of me?
Yeah,
so this is a different thing per layer. Then, obviously. It's not something
just-
you provide once and then everybody gets the same background.
No.
Depending on where I am, I see a different background behind me.
Yes, because you're sampling this
Okay,
layer,
okay,
you are here, and from there, what's below me, no?
Yeah.
What's my background here? What's the background of someone that is asking me, which is handing over, okay, this is what below you, the background somehow, and now it's up to you to
but
compose
from
yourself.
the perspective of the layer, it could also be just called initial value. Don't care where it comes from. For this value, it's just that I have an initial value, I compose on that. Just trying to put it in different words, no? It's not important
Yeah,
for the layer, it's not important that it's.
it was just to
background.
follow yeah,
This
this
Photoshop.
paradigm of
Yeah.
having
It
a
makes sense.
background and composing on top of it. I don't know. I think it's because it's also misleading if you call this is not a value, as you see, it's a function.
Yeah.
You will see why.
Yeah, okay, but
But
initial
still,
starting
But
point.
what happens if, like, I get it, but what happens, imagine that you have like many layers, and then from the perspective of the composer, like the layer, let's call it layer A, and then after that is a layer B, and then after that is layer C. Each of them, they have a background value, and say we basically give the background value something, like as we did right here. And when you have this compositor, the layer before
Wait. They don't have a background.
They get it.
They get it.
Okay.
It's
The
part
first
of
one
the
gets the
signature.
initial value.
Mhm.
So the most, so when you have a sample, the only, if we look at the signature of a layer, okay, the basic signature of layer, it's there's one function in the layer, it's sample, right? And what's the signature of that? It's background function, sampling position, and alpha, and these are inputs.
Mhm.
So they come from, so this layer doesn't hold any background, obviously, it doesn't make sense. It receives a background from downstream
Mhm.
so that it can produce something and compose itself on top of that.
Mhm.
And so when we look at this graph, for example, where we are here, okay. This value, in the end, it's one of these leaves, because the entire magic of evaluating these graphs and evaluating the final value happens at the leaf. Because all these nodes, they become backgrounds of and cores of the other clips, other layers on top, till the very end, where you have the final layer there, which receives all the previous layers as backgrounds, and then compose itself on top as the final value. Right? It's like
the node here, sample layer 1D, has a background value input, right?
yes.
So if you set that,
So-
that's kind of,
Let's say that this is -1, no? And we are on the clip there, right? Now this clip doesn't have any blending. This by definition is like opaque, and that's why we simply get this value, no? But let's say that we have positing model. We can say blending. Let's put additive. Oh, come on. Additive blending model. We want to use additive for this clip. As you see, let's put some random, so it's here. The value, say our background is 0.1. Let's put another quote. Yeah. Okay, so the value now, we sample this clip, okay, and this clip is saying, okay, instead of, let's just do this.
yeah.
0.5,
Adds.
actually, yeah. So if we don't provide any, which means, okay, it's just opaque, that's what we get, because the background of this clip, when we sample the layer,
Is
doesn't
ignored.
count, no? Just simply opaque. But if you say, okay, blend on top of that, suddenly the background is, the final value is 1.1, because the background was 0.3, let's say, and we adding on top of that our value. So the output is 1.3. So yeah, in this case, this value is composing itself on top of this graph of layers, and then with this blending model. So if we go back here in the compositor, what happens is exactly that. We can arrange clips, and each one of them can say, okay, I want to add myself on top of the background. I want to multiply myself on top of it. If we go back here, we say multiply blending mode instead. And we put another for this time. Okay. But you see that my value goes from 0 to 1. Okay. Now it's basically multiplied with the background, which is 0.3. So the output will be
In the range.
in 0 to 3 because I'm just multiplying this with the background.
Okay, but you're still in the context of this one-dimensional timeline.
Now this works. I mean, if I do this,
And like, I mean, this background thing, how does it work? Like if you're arranging values in a 2D space, then you overlapping 2D shapes and the background.
and now I'm very proud to show you this patch. Let's see if it works though. How can I get rid of this?
But we don't see it on the stream. It's just for you.
Yeah, but it's annoying for me. Is there a way to collapse it, hide it?
I'm not.
Top to top.
Yeah, but it stays there.
So annoying.
Maybe
If
when you
you
click
get
away.
in the chat, just
Yeah.
No.
because it was only showing with when the chat.
If you read the messages on the
Read the
chat, maybe
message.
it will go away, no?
Where?
Just click on the chat. Yeah.
Yeah, okay.
Thanks. But it's annoying. Okay. Let me try to open again. I know it was oh shit. Anyway. It was here. Compositor.
Yeah, but it crashed.
No, I don't know what is it, but
It,
let me try.
it was
Ah,
taken
yeah,
with-
the preview.
With a 20.10, 4.10.
No, but it's fine. It's just need to. There's some probably some broken connections. Yeah, but I renamed some stuff. That's it. Well, yes. There we are. Very proud of this. It's a rasterizer, basically now. So, look, just clarify. This is my sample layer 2D, and this is the coordinate of this 2D space that I'm sampling, right? I'm moving around and I get a different value.
Yeah.
Where I sample, right? And just to preview a bit better the space, I made like an array and sampling pixels, so to say, no? This is like a rasterizer. And what I get is this: every position of the space returns that value, right? And as you see, it's it's a canvas where I can. This is a compositor 2D now, where I can have, and if we go there, you see now we are in the 2D category, and there is this compositor 2D, which similarly to the interpolator 1D, introduce the concept of, okay, I'm a compositor 2D shape, and now implemented a few of them. I can have n of those, no? Like there is a circle, a rectangle, round rectangle. These are just some, and I can place them. You see, this is my compositor. I can have shapes. I can locate, place them. This is the size of my round rectangle, and this is linked to a layer. Okay, but the key element is that I can place shapes there. Okay, and I can define, okay, some specific things to the shape. And see, this shape here is connected to a layer 2D, obviously, which returns this value, right? Which is, something that it generates into my patch, whatever. But this is just the rectangle, the round rectangle is the way this layer embodies into this compositor 2D domain, right? Just the way he embodies that, so I can access it in a certain way. And and as you see, each one of them compose itself on top of the other.
Yeah.
Like I said, this one, for example, let's check this round rectangle shape, now doesn't have any compositing model. As soon as I put additive, you see that will just compose itself on top of the background, which is this other rectangle, no? There. So
And here again, the order in the cons is what's saying what's behind me or
Yes.
below me. Okay.
yes, well, Not really, not really. No, because the compositor is a bit more advanced than that. So he has a stack index. So in which we will represent it here, no? Depending, I can arrange the clips, and that define how the order in which they get decomposed on top of each other on the background. No? So we will visualize like that.
And can you set like give a different color to the root background just to see how it's reflected?
Here,
Yeah, just to see how it reflects in the.
so well, let's say that now.
Like if you set white here, I would expect the background to be all white and.
But that one's
Oh, sorry, yeah, I just put it here. Should put it there as well. Yeah.
Okay, yeah.
So it was just on the cursor, but you see, this is the background, and they blend on top.
Yeah,
Where there's nothing, obviously, you just get the background.
yeah. That was.
Beautiful.
But do you see how this scales? It's so concepts are clearly separated. So you can suddenly this background notion, the blending composition is something different from the way we embody things. So we can immediately just building a matrix has 5 minutes because it's just okay. The way I wanna correlate things is just switching between them, and I implement a switcher instead of an interpolator, and suddenly I can have all this complexity, this blend, this composition, this nested graph system, just in that way, in which it's a space in which I can arrange things into slots, and I can switch between them. So very confined task, which doesn't interfere with all these other levels of topics, so to say. And look, you can get fancy and say, okay, I have a shape here, no? Which is a rectangle, okay, this one. And what happens? Let's say that when I sample it, okay, when I sample this shape, what the shapes get, being a layer 2D, is a 2D coordinate as an input, no? Saying, okay, give me a value in that coordinate. What I'm doing here is, this is like an implementation of a layer, which is, say, transports to 2D. It gets a vector 2D as an input, because I'm asking for a 2D position, and I can describe it, okay, I want to pass, I want to transport this 2D sampling to a 1D sampling, because up there I have an interpolator, right? Which is this one. But it's a layer 1D, no?
Okay.
So what I do is, okay, when I sample these shapes, I'm asking for a 2D coordinate, and I'm just taking the X, right? And I'm using it in this range to sample a 1D layer, which is this one. And that's why you see placed like that, right?
So you have a track.
So let's say, yeah, let's do the Y coordinates instead. Finally, I'm sampling this 1D space using the 2 with the other axis, no? And so it's just then thinking, okay, layers have dimensionalities, but I can always pass between them. I just need to describe how I interpret these different coordinate systems, right? That's why I can have a shape, like this. Let's say that this is an interactive installation, and I'm tracking a person moving around, and I can say, okay, when you are here, for example, just sample a timeline, for example, no? That I doesn't make sense maybe, but still, I can just think about domains and like these interpolators or blender or like compositors. They're just ways in which I want to organize my data, and they can be nested inside each other. Like, like for example, the matrix, no? When you get back here into my matrix, it's just one way to arrange data. I trigger a clip and want to sample it, but maybe this clip is a timeline, right? That goes to another space, which organize data in a different ways, right? But this is the key part, is that the way I organize data, it's a separate thing from what is the data, right? Once you keep this distinction clear, then it's so easy to just find and invent new ways to treat, to organize this data, still using the same material, no? As
so now if we go back to the patch, I have actually 3 questions. The first one is that, so now the value you're providing is basically the colors in RGB, right? So assumably that this is generic. It can be anything.
It can be any.
It can also be custom data types.
Yes.
Okay, and then so say we have custom data types, and I don't know how you could bring them to shapes, like embody them. We have a keyframe and clip, and what is also the difference between clip and keyframe? That was all my question.
So, well, let's open again this one. As I said, these are, so if I don't connect anything, if you don't provide any data, you see that this is the generic patch, no? It's like I can ask for an RGB, and suddenly it expects that the layer is expected to return an RGB. This annoying, but we'll fix it. I can say the type is as a vector 2, and so you need to return a vector 2 there. No?
Yeah.
So the dimensionality is completely separate topic from the actual nature of the value that the layer returns. No, so 2 completely distinct things, and that's what Alchemix does. It just takes care of interpolating, blending, any sort of type, right? And it just takes care of that. Layer X add on top of this other layer, this other concept of spaces and dimensionalities, but it's just something on top that doesn't touch the essence of the treating values, any type they are, and operating on them. Compositing them on top of each other, interpolating. That's a very specific topic. And
in terms of object-oriented approach, would you consider this to be within the custom data type or out of the custom data type?
So,
like imagine that we make just one imaginary data type, right? We have to create my object, and then
So let's say, well, here. I don't know.
Would be an example would be a movie clip, no? So you have your own idea of a movie clip,
or I mean,
no?
You mean like a video, texture?
Yeah. Well,
and you could. This can be anything. Okay, so it can be everything. It can be a texture. You can. This is T, which means that you can put any kind of type there.
Let's get the good old particle system example. So we have positions, and then it is a vector 3D at the position. It has a color, and also it has like a I don't know. Yeah, it has. I don't know. It has also maybe produces some sound as well, some noise at some point.
Simple type, right?
Maybe just put this string as an ID just for the sake of.
Let's put string. Okay. So particle create. Well, let's just let's have an instance. That's my particle, right? I can have a particle here, and a sample there, I just get a particle, right?
Yeah.
It's obvious. So if I plug this, because as I say, this is just like inside here, nothing happens really. There is just this, huh? Let me just for really just getting. Well, let's what can I say? Because you need to provide a background, but it's fine. Layer 1D. This just to see that the essence of the essence of the essence. Just some constant background and something which we don't need. So this is the essence. This is a layer. It's something that you can sample, and this is the operation that you call over that layer when you want to sample it. No? This is what happens. So when I sample in this location, I get a value, and what I get is that one. Since it's using generic, I can really plug any sort of thing here. I will just get that out. So this is the simplicity of the layer. When you start to do more advanced stuff, like for example, in an interpolator, if we say that our well, let's just copy it. So we don't. Let's just one. Yeah, just to break everything. If I connect that here, sorry, I need also the layer. So I want to have this layer which return when I sample it returns particles, right? As soon as I connect it here, I think I expect to work. but probably when we sample, I don't know. Okay. Well.
Yeah.
I got a null object here. It doesn't work. Why? Why doesn't it work? Because the interpolator, we say that it's been more advanced than simply asking for a layer. No, what it adds on top of that, it gets some layers, some shapes, and ask because he wants to ask for their layers. And then once you choose the shape that you're interested into, just take the layers, sample them, and interpolate between them. So there is this functionality of interpolating between them, right? Which is a key part of this interpolator. But when we ask a value to this layer, because we want to interpolate, what does it mean to interpolate between a particle and a particle? Doesn't mean anything. No, it's not defined. So then the whole point is that it's not. We're not stuck because fortunately we confine quite clearly the problem. No, and this because we are talking about just interpolating and between these types, and this is what this library AlchemX does exactly. It takes care of manipulating and synthesizing values, types. No, so and with this library comes some set of functionalities where you can say, okay, I have my custom data type, but also I can register techniques where I describe, okay, this is what you need to do when if you want to interpolate between my two instances of my type. So once I describe and I register these techniques, say, okay, because probably inside I need to interpolate between the position, between the color, and I take the first ID, for example, I don't know. And I register this as an interpolation technique, then the library can deal with that type, no? The interpolator. And then it will just return a meaningful output, no? Which will be a particle, which is the interpolation of the output. Okay. And once we make sure that the functionality works at the very atomic level, no? Okay, that the essential functionality works, which is just interpolating between these two types, then everything it works perfectly, and I will have a timeline of particles where I can define states of particles. They can also be, as we said, can be animated, but it can be alive particles, and I can animate between them. I can interpolate on a timeline. No? I locate them. I say there's a keyframe, which is one particle, a clip, which is another particle. So when I'm over the clip, I will just keep using the value of that particle, and then I can have another keyframe there when then I connect to another particle, for example.
And how does this register part work?
Can we see that? Is it too
Uh,
much?
Or yeah, maybe.
No, it's fine. If we go this alchemics, if we go there, it's the three. Why did I start the recording here? Now it's started.
But we did clap and everything.
I don't know. Well, we missed already more than 1 hour. Eh? Anyway,
Yeah.
alchemics. Is it, oh. Break.
Anybody else? No? Never mind.
You want to.
That should be. That should be. You like it. Let's see what further. I also have two more others there. Sure. Thanks.
Sorry.
And you guys want to have a break? I mean, we do that and then we can have a break or something.
Sure, yeah. Shall we have 5 minutes break? Okay. Shall we have 5 minutes break?
Yeah, maybe a bit longer,
Okay.
Yeah. 10.
like half an hour just to prepare something. I don't know how long you guys need.
And then we can take like the lunch break now.
There's a lunch break at 1, though, huh?
Ah,
Yeah,
I
okay.
see. Yeah, okay, then we make 5 minutes now and then
10 minutes. 10 minutes. Okay. At noon we continue. Yep. Started.
Everyone is meeting. Back.
So we are back, and as Randa was suggesting, maybe I could do an introduction to this call. And just to say, okay, I'm presenting Kairos. This is the result of this research in multiple years, because I think that now is mature enough to share it. It's already open source, but so far I've been the only one together with the developers of before to somehow develop it. And now I think that concepts and behind it are mature enough that I can communicate nicely. First of all, we committed to an architecture, to how things should be, and we can clearly discuss about that and explain that. So now is the time in which we can onboard, we can build a team of people to work on it, with the aim of targeting, ideally, I don't know, Christmas, to have a nice timeline or other tools as an outcome of this research. So the scope of the camp would be not to. I wasn't thinking that we sit down and implement stuff here. We will probably implement stuff and fix or extend, but the main goal to me would be to structure a roadmap and a team, see who is interested in participating, how we can assign tasks to who is interested in doing what, and planning the next months of development, no? And so that we can structure a bit more, and also tackling certain side topics like how we talk about the project, the public, like repository wise, what's the status there, communications. So something similar to what we did for Fuse project. So making it more official and as a shared journey and project. So it would be cool to have a website for this, I think. And well, there's many things to talk about, and we'll go back to it. So where were we actually?
You're about to show how you can implement those blending operation with your own data type.
Yeah, Alchemix. So having a closer look at this, we say that there are so far these three aspects into this library, these categories, which one is interpolation. If we go inside here, we see that there is like already an interface for the interpolation model. An interpolation model is basically how you describe a technique, an interpolation technique. And so we have step interpolation model, linear interpolation model, twin interpolation model. If I go inside, I have the basic settings that are required by the technique, no? So transition and twinner mode. So yeah, this is the model, that the settings of the technique. And then there is there are different applications of those techniques, like the interpolation one, for example, which implements high-value interpolation function. This is probably something that we will need to implement, not for a particle, for a custom data type. Here I describe how to interpolate between A and B. And in the case of the twin interpolation, I just get a scalar as an input. This is the main operation. And I say, okay, I get a scalar, and these are the peculiarity of this twin interpolation is that I have transition and mode that can twin the scalar to then interpolate lerp between these two. Just an implementation of the twin interpolation. Then I can register these techniques using these regions. So they basically get registered, and they are available for the final nodes that we use, which is the interpolate node. Internally can be scary, but it's simple somehow. There is a node that, depending on what I connect to it, it checks the type and asks for a service. Is there anything? Is there an interpolation technique registered for this type? If yes, this is it. I instantiate it and I use it. Right. This is what happens under the hood. And that's why we describe, okay, the settings of techniques, we describe the actual implementations of this technique, and then we register them so that they are usable already, accessible. In order to implement some of these, I also had to implement, because the most essential element of an interpolation is the lerping between things, no? So I need to make sure that there is a lerp implementation for types, no? Like for Boolean, what does it mean to lerp between two Booleans? I invented my own lerping here, saying, okay, if the scalar is bigger than 0.5, then takes the second one. No? This is already an implementation of the lerp for the Boolean, so that now these techniques also work with Boolean, because each one of them will use a lerp, and VL will, when on compile time, when it basically instantiated, or runtime actually, when I instantiate the interpolator, VL knows, okay, there is a lerp for Boolean if I provide a Boolean. So it implements that in implementation, and then I can use this linear interpolation with Booleans. Okay. That's why I had to implement certain basic nodes for the type, for the Boolean. Then for each type also, I implemented certain techniques, okay? Because not all the techniques are maybe meaningful for the types. So let's say that yeah, it's just to say, okay, I have my custom data type, for example, and this is how I first of all I lerp between two of these functions, and then I can say, okay, for this data type, I want to have linear interpolation or pre-interpolation, or I don't know, a custom interpolation. So there are functionality to register. These are the operations that I use to register things, but we can directly look into this. When you are in your patch, you create this region, register services with this operation, which as an input has IBL factory, right?
Mm-hmm.
And so once you define this operation with its name and it comes with this input, it's a special thing that VL picks up when he starts and check and so it's the first thing that runs, so to say. So here you can, in this operation, you can register services to the factory. And here we are using, as I was saying, we are using this operation that comes with the library, that is register step interpolation, or register linear interpolation. So I can say, okay, with my type here, I want to register this technique as step interpolation technique. Or maybe I could say, I want to define my own step interpolation for my type and register it as step interpolation to the system, right? Because we know if we start dealing with complex data types, sometimes we need to have full control of how we want to interpolate and what kind of, how we want to interpret the techniques for the type. So anyway, yeah, we can, just to show you that we register techniques in this way for custom data types. And same happens with the blending, no? Same approach. What's happening here? I have blending model, which is normal, additive. These are just models, and blending implementations. Normal blending, just pass the value itself. Additive takes the background and add to it. Multiply, just multiply blend. This is like, again, as a multiply blend. Yes, it's an adaptive node because we can implement for each of the types. We need to implement. What does it mean to multiply a particle by a particle? Well, if we want to use this blend mode, we need to describe really what this means to multiply, and that's why again here in the Boolean we say, okay, what is add mode? What does it mean to add two Booleans? It's really just, I don't know. Here I implemented like that, or to subtract or multiply. I don't know. You need to tell him what does it mean, so that he can then use it.
All this is exposed to this is what I would do in my patch outside of Alchemex, yeah? This is exposed to me as an end user to register my own techniques and all that.
Yeah.
Yeah, because even if you do this registration step in your own documents, it's still picked up by the library because it's registered.
Yes, it's just registering to the library. So that's why
the
there are
register service operation has nothing to do with Archimedes at all. It's a real thing.
yeah. So that's it. Same for the compositing. Compositing model with, as we say, it's a transparency model, blending model. And each one of them is like high blending model, high blending model, high interpolation model for the spread count, for the value, two aspects. This will change, I think, but still the concept is that for each one of them, you can register composition service for this type. And since everything is implemented for integer 64 in the other two categories, it should be safe because the compositing just use the other two categories. So since all the basic nodes there are implemented for integer 64, then everything works. So yeah, you can use this this library as an independent thing, completely off topic, detached from Kairos, from layer X. This is just a library by itself to manipulate values anytime. And this is what I was saying, that if you connect there, you probably get like here it says now it's stopped. But you say, okay, I found everything that I needed, that there's everything implemented, or not. Yeah, that's important. So going back here, so let's go back to the layer topic. Let me just
Subs, the console as well.
Yeah.
Imagine it tells you what it didn't found.
So let me just import this, whatever reference. It's good. Okay. That's it. So we saw this more complex example, but so we see what's the pattern here, no? Having the layer aspect as something, the way we embody the shapes, these layers into shapes, depending on the domain that we define. This is another aspect of it. So we can embody them into a 2D space, with 2D shapes, and then composing on top of each other. This is quite confined task of these nodes here, but then we can have embody layers that embody into a different context with 1D shapes, whatever, that gets interpolated. So if we think about it, this is well, just to go through again, this is the layer aspect. As I was saying, this is the signature, whatever, but you can, as I show you in the patch, you can nest layer inside each other. Then, so at some point, then you can start building complex graphs, no? And having like a matrix node, it's like one of the layers then is connected to and injected into another context, which is an interpolation node, which is injected into another compositor node, is an interpolation. So that's why you can nest and have multiple spaces and still being part of the same architecture. So then everything boils down to, once we define, okay, the layer, then we can think about many ways in which we want to operate, no, with these layers. So the interpolator 1D is, we saw it, no? It's just this interpolator introduce the knowledge of this space where there are shapes, okay? And so I can place these shapes into this space, and interpolator as a way to access the space and relate to the clip, to the elements, to the bodies, to the objects in the space. So if I'm here in the middle, I will interpolate, I will take this shape, and interpolate between them. And what does it mean is that I sample this layer, whatever it is, I sample this one, whatever it is, wherever it comes from, I don't care. It's just a layer that I sample, and then I interpolate between them. And this is what I return, being myself a layer which can be sampled from someone else. So, but this is just one way to get these layers here and embody them into the shapes. But what about, as I was saying, the metrics? No, if you think about the matrix, Ableton is just a vertical set of channels, like there are switches, like, you know, and how a switcher,
Sure.
when they would work, simply I can put clips there, I don't know, slot, whatever, into this slot, and then I can either providing the sampling position, or maybe locally, I can just provide, if I just want to have a tool that I want to play live like that, I can say, okay, I want to go live with this one or with this one, just choosing the index, and then whoever samples from downstream will just sample this clip or this clip, which points obviously to this layer here. So this is just another way to take those layers, embody them, and accessing them. It's just another way. We can also think of an interpolator 2D, for example, where I locate, I can put objects which are just positions in a 2D space. And this is a 2D interpolator, which means that when I sample it, I provide a coordinate, 2D coordinate, which is my sampling position, a locator that goes around. And whatever it is, it just pick, maybe using a Delaunay triangulation, it picks the three most meaningful ones and just interpolate between their values, right? Still, each one of them will be called, will be sampled, and will point to the upper layer. So just another way, another set of bodies, it works in a certain way into the space, and this object here deals with them in a certain way. Compositing on the, we are familiar with it because this exists already in the current Kairos version that is available. Clips there, then I can arrange, change, move them up and down to define the order in which they get composed, and they get composed on top of each other like that. This is what I implemented in that we saw. I put shapes there, and they get composed on top of each other. And you see, it's exactly the same thing, right? Yeah. But from a different perspective, in a 2D space, right? Simply, it's exactly the same thing. We could also implement like an automator, like Automata UI. Think about it, I define states, I can define a graph, right? I don't care what is that, they are just states. And I define a logic that defines how the state machine works. And then when I get an active state, it points to something else, right? Yeah. But the concept is the same. Here I define the nature of a space and how I relate to the objects in the space. Yeah.
In this example, though, I would need to, it's very spatial, right? The states would need to be laid out dimensionally so that I can.
Wait. This could be a zero-dimensional space.
Okay. But this is like a switcher. This is kind of like a switcher.
A switcher is 1D, I would say, with integers instead of a float. Maybe, I don't know. It's up to us also to how to implement. Maybe.
But what do you pick? What is the sampling input?
So could be maybe in this case it's not meaningful to provide a sampling coordinate, right? Okay. So it's in this case, we might be interested in delegating to upstream. You, automator, you deal with your shit. I just need a value. Okay, I'm not asking for a state. You have all the logic to deal with those states and returning a meaningful thing out of that. So I don't even need to give you a coordinate. I just expect that when I sample you, you should do your machinery and then provide a value to me. So in this case, the fact that they are organized in 2D here doesn't mean that this is a 2D space that I sample. It's just a visual representation of some logics, no? That is handy to have in the 2D space to better organize, right?
But then, like, it still can be similar to the first example.
To
which feature? No, what was that species up there?
This exactly. So
Unless you want to blend the states.
the switcher, I think that you could provide a sampling position, no?
Yeah.
Because you could provide the index that you want to switch. You
Yeah.
want to,
Yeah.
right?
Yeah, which in that case, the linear one. in the
For example,
picture,
let's say that it's a 1D, still
Yeah.
accepting a float 64 as an
Yeah.
input.
Yeah.
You could say, yeah, you could use just the integer part, no?
Yeah.
To switch between the clips,
Mm-hmm.
right?
Isn't this suggesting that maybe that input type should also be generic?
But it is generic.
No, this float 64 thing is a float 64.
Yeah, for the
implementation.
implementation.
Ah,
I layer 1D.
I see.
Then there is I layer 2D, which has as a signature as a vector 2. But the most generic interface is I layer, which is an object polypath, right? It can be anything. This can be, we can have a 3D space, why not? We expect a layer to be a 3D thing, like with Stripe, we implement some shapes that we put into a space, and then we have a locator, sampling position, 3D that goes around, and maybe, I don't know, I didn't do it here, but we could have a distance, sign distance field here, no? So depending on where you are in the space, check the distance from the objects and sample them and use their values in a certain way, depending on the distance, for example. I don't know. Same with 3D. So this is very important to think that, okay, the dimensionality is not bound to certain types, or you can implement anything. Imagine that we have a 13-dimension space, like in string theory, no? 11, 12, I don't know how many they are now. They are adding on top. But we have an 11-dimensional space. Then if I want to sample, if I want to get something out of that 11-dimensional space, I need to provide all the coordinates for that. Imagine we have a neural network. It's a multidimensional space. We can define a layer which is a multidimensional space. No, it's a vector space, right? Multidimensional space. And if I want to sample that space, I provide an array of 128 values, which are all the coordinates that sample that multidimensional space, right? It's really up to me to implement, to invent these different spaces and giving them properties. Then it's also, yeah, up to me to define how to deal with objects in those 128 dimensions, but that's maybe something that is for another machinery to do that. But this is just to say, look, these are all the same. What changes in these completely different tools, that apparently they're completely different, no? But what really changes the essence is that just in this confined domain, we are giving a body to these value sources, so to say, or possible. We are giving them a body, and we are describing how we deal with these bodies into this domain. That's it. And that's why once this is clear, then it's trivial to implement new ways to deal with it. And once you implement a new one, automatically this is part of this complex architecture. So it scales up incredibly, because suddenly it can be used in any other context. So once we implement an interpolator, then you can use it and build a timeline out of it. So where every track just use one of the interpolators, okay, and so on. If you want to build a matrix, just implement the essence of it, which is a switcher layer, and then you just arrange it. No, you have a matrix that will have many channels, and each one of them will be, in the essence, will be a switcher, right? So it scales up, and that's the beauty also, because even like when you start thinking like UI and that stuff, it would be cool to address this topic also in this modular fashion, where, wait, can we build a UI just to edit some shapes in a 1D space, right? Once we tackle that, the very essence there, then we have a timeline basically, because that's the essence of a timeline. All around, everything that's around is just, adding on top of that. But this could be also a tool by itself at that point that you can put in your patch, and you can attach shapes and you can sample values like we were doing in the patch here, no? Why not? This is already a library, it's available, and you can somehow organize values into the space and sample it. Outside any knowledge of systems and set of parameters, complex timelines with a collection of just something very precise and specific, and you can already do it. Okay.
And there was one more thing, was that a stack index? You had one?
Where?
In one of the, I think one of the notes I saw there was a thing called index.
Here.
Index, something like this.
Yeah, because this is a compositor today.
Yeah, it's a compositor, yeah.
So here, stack is basically the index in the
Yeah.
order in which you stack things. No?
Yeah.
So you can pass them as in a cons as a list of
Yeah.
shapes, but then they get sorted by the index.
Yeah.
So that this triangle if it has 3 as coordinates gets put on top of the other 2.
Yeah.
Because the order matters.
So it doesn't care how you're
No, it doesn't care.
the code, it just the stack
Yeah.
basically tells the blending model, compositor model something. That is basically how does the blend
Just defines the order in which the clips will be called,
yeah.
and they will build the background.
Mhm.
Also, no?
And do you have the same thing for example the switcher or for the switcher basically you have an order like
Well, here you don't need it because they
So
don't get
you want
composed on
that,
top of each other.
Mhm.
You just switch between them, right?
yeah.
It's just because this is really related. The fact that we have a stack index is because we know that we want to compose them in a space that can be overlapped. And we know that when the shapes are overlapped, the order in which we compose them matters. Clear defines the output.
Yeah.
No? So that's it's a very important feature. That's why we introduce it as a way to organize them. But in the case of a switcher, we don't need. We are just switching. Okay, give me that, and then that. You don't compose these objects on top of each other in any way, right? Or so we don't need an index for that. What they will have is just a slot index, right? Because they can place this clip can be placed here or there, you know. Potentially, we could think, okay, let's do the same that we imagined for the timeline for the interpolator, where we say 2 clips overlapped.
Mhm.
There, we want to also have this feature of compositing them together, right? We could do the same here, no? Saying, okay, as it is, we generally mean, okay, there is 1 clip per slot. Imagine that we put 2 clips in the same slot. In that case, we could say, well, when we play the slot, we want to also compose them.
Mhm.
And in that case, maybe as a stack index would be meaningful because you could change the order of those. No? But it's really confined to how I want to operate with them and what kind of functionality I want to have into this very confined domain, right? So let's see. Questions also from people there. Is there any question from the call?
Not in the chat and not on Riot as well.
Okay. So I don't know what to do because still we didn't talk about Kairos.
Yeah, so the question is, have we covered the essence of the two others already, or is there some elements?
Instead of going to Kairos, which I would do after lunch, I would maybe let me think. We can maybe play a bit with this.
I have another question. If I already want to play.
No.
Yeah, okay,
I play
so-
just to arise.
Yeah. So if you go back to the Miro board, you have this compositor, and then there was a switcher, and then actually the compositor part, and there's one of them is like automator, right? So the automator is like it gives like the
Automata UI.
Yeah, yeah, exactly, like a finite state machine, sort of,
Yeah.
different states and so on. But then, if using the same concept, like you click somehow, you can implement the behavioral tree as well, which is basically same sort of a decision-making mechanism, or decision-making sort of, basically you have functions, and these functions can be inside different functions. Like the characters in games, those that they die very quick, you kill them when you're just going to your goal, like the easy characters, they make the decision by themselves. They have like a complex, for example, I don't know, behavior structure, and that is a complex of infinite state machine. So what I can imagine is like that would be basically a combination of compositor being inside, like a different layers of compositor, the composition into compositor.
I just imagine a very weird tool in which you have a rectangle here, you have a bunch of particles, right? Each one of them, imagine these are the particles, each one of them is connected to a layer, no?
Yeah.
And you pick an initial one, and then you start the simulation, and they like box 2D simulation, they collide. And then every time this particle collides with another one, it just switch to that.
Yeah.
And I sample that state.
Yeah, exactly.
And then I build an entire system which is its own weird logic.
Yeah.
But that the key is that when I sample it, I just ask what's the current state, and through this simulation, weird simulation, I just suddenly pick one of the upstream values, no?
Mm-hmm.
So, but just as a very confined ways, I define a space, some rules, some items, and it has its own reality, like it has gravity, and then it's just one way to access that data and continue to sample upstream.
Mm-hmm.
So you can invent any sort of things. You know, these are just few examples of what's, I mean, very easy to grasp, but you can build super weird things. And I'm really hoping also to our suggestions, you know, to get really weird in this regard. And as you noticed, we already pointed out, we sample these machineries because they are layers in the end. Also, we sample them, and they have a dimensionality. So either they are 1D or they are 2D. So when we sample them, we provide a coordinate, but then that's something that we pass from downstream, and each one of them can do whatever he wants with the coordinate, right? Like as we saw in the patch there, we can use it, or we are just in, I don't care. This is my value, and the way I produce it is just up to me, right? So, so then these are really private spaces in which I can do whatever I want. Like the state machine, for example, is not using the sampling position from downstream. No, he has his own logic. It's like a tool, like I don't know, that has his own logic, and maybe takes some inputs from another device or whatever to trigger its states, right? And has his own state, is a living thing, and due to this nature, is independent, and it just define by itself what it will return when it will get sampled, right? And so they are completely independent. But I would say, if we imagine like using building a matrix like in Ableton, there also you want to be independent. Maybe you want to have a matrix there. You actively, as a user, you want to just play and trigger clips or preset. No, there it's something that you operate locally there. You're not waiting for someone to trigger which slots you want to have, right? So you're not really, in that case, you're not using the coordinate that comes from downstream, right? So it's in that case that this tool would be independent, and it's up to you to manually trigger stuff. You understand?
I would like to try to make a few statements and see if they're correct.
And the water.
Yes, correct. So we have these two libraries, Archimex, Layer X, and they're completely independent, not related to each other.
Well, not independent in the sense that layer X uses also some inner parts uses layer
Okay.
X.
So layer X is depending on Archimex.
Yes,
Yeah.
the structure, the dependency structure is this one, right?
Yeah.
The layer X uses
Yeah.
Archimex, and Kairos will use both of them.
Yeah.
And
And in layer X, or the layer X library introduces the idea of a layer, of a shape, of, well,
shapes, possible
Yeah,
shapes, yeah.
possible layers, possible shapes. So a layer and shape. And then we have two more concepts, which is one is interpolation and one is composition.
So interpolation and composition are related to Archimex. Archimex takes care of them, right? Of interpolating between values and compositing values on top of each other.
Okay, so that's exactly what I wanted to get at. So
And that's why once you define this very simple task, essential task, how do I interpolate between this value and this value, you know, it's float or this is a very essential task, and that's why it's done by Archimex.
Let me try again. So we have these two libraries, Archimex and layer X. We start with Archimex. Archimex is a library to do two things. It interpolates between values, one feature, and it can compose values.
I would say the main features are interpolating and blending, and compositing is just a combination of the two. Right?
So interpolation is clear. You give it two values and say
blending is this, no? Okay, I have a value and I want to like synthesize the output and with this blending mode. So additive, it just add B on top of A. Multiply multiplies that, right? It's the essence of blending. Then I have interpolation, which is interpolate, learn between two values.
it's interesting because somehow they're similar. No?
They are not in reality, yeah? They are not, if you think about it. Blending.
They both take two values and you tell it how to make one of them. So
yes, that's the essence of Archimex, that synthesize a value out of collection, like a set of values.
Yeah, but you have two different ideas of how you do this. One is planned, and one is
And keep in mind that this will grow, this library, because now it takes just two values, but you could have operators that interpolate between three values. And that's what will be needed here, for example, right? If we want to interpolate between three objects. But this task here, in the essence, is something that we will implement in this library, which we need to just deal with the raw numbers and say, okay, this is how I interpolate between three objects.
But I still like the first library provides the possibility of blending
interpolating
one to the other, and then with the next one in the next library, you can basically use that to make it. You make use of it or more.
Make use of it.
Yeah.
Adding this interpretation. Okay, what I'm blending is what is compositing is the background, which is this notion in the layer domain. So I'm using this operators here to blend the background that comes from the layer system on top of the value that the layer will produce. No, just one way to use this very basic functionality, which doesn't care of anything else. Just okay, I have A and B. I want to blend them. A and B. I want to compose them.
So if we go to the GitHub of Archimex, to the README.
Oh, forget about
it. What would I expect to see there? Is like
at the moment,
I don't know what's at the moment, but like
there is one star, it's mine. No, it's too much.
But the README. collection of operators to manipulate data.
It's
Operate
straightforward, it's
category.
all,
Yeah, no, I'm just trying to help now, like improve this already on this
But this
very low
yeah,
level.
but you know, this is
What-
the,
How can we, what's the essence of these things
Yeah,
in
exactly.
words?
and this is perfect, this is exactly what I wanna do, no?
Yeah.
So this week, my aim is, okay, we have these libraries with very clear tasks. So let's clarify us and communicate clearly about
Exactly.
those and how mostly they just make use of the other without really interfering. So this is very old thing, but that we will need probably to extend and clarify and yeah.
From a philosophical stance, wouldn't you be able to say that interpolation is also a blend? It's like a specialized blend.
I would say that interpolation requires requires having two objects there, and the result is not is somehow doesn't modify those two objects. It's not meant to be like a manipulation of the nature of those objects, just passing from one to the other somehow. Blending is more alchemic in that sense. It's like dealing with the substance of A and B and the quality of those. I don't know what to say. Like I don't know that there are certain blending modes that you can't describe with an alert, right? How can you learn if you want to have an additive mode?
No, of course.
So,
But if
philosophically, to me, it feels like manipulating. That's why they are composed. They are also taking part of this. Taking part of together they basically become the composition of alchemics. I should turn off notifications.
Yeah, so we have Archimix that does that.
Just
and
deal with
has
the
these
values
Two features currently implemented, planned into the structure.
and compose also.
Is a third one.
Yeah, it's the third one, which is a combination of the three.
Of the two.
Of the two, yeah. So where you provide A, B, alpha, and compositing model, which is exactly what we need when we want to compose the layers, no? And this is exactly what it is internally. It just, from the compositing model, it takes the blending model to generate the value that then will be interpolated to get the alpha, no? With using the alpha. So this is the machinery, the entire composition process, no? When you want to compose something on top of something else.
But earlier you corrected me and said composition is not part of Archimix. So there's a clash of terms now somehow. No? When you said composition is rather what?
No. I say that no, because we're saying that the main two aspects of this library is interpolation and compositing.
Mhm.
I would say no. Maybe
No.
if you want to really find the essence, maybe the big one are blend and interpolate, and then the other feature that
Is
comes with the
already built
library
on top.
is a combination of those. Yes, you know. But if you really want to go to the essence, maybe those two are the most
Yeah,
essential,
I understand.
blending and interpolate.
Okay, and now back to layer X. What statements can we make about it? Layer X is introducing
I like this title here. Layer is the medium.
fuse together values with the nested.
It's like, providing a domain
Think about it,
in which you
it's the
arrange.
medium. It's
arrange
what
values.
glues together values into a compositional graph. So is the medium. What is the medium? Is the way we access things, no, and where things are, and
Or context for those
Context.
values to live. They live in a context which is there 2D, 1D, 3D, whatever.
yeah. that this medium is also as the metaphor, the act of accessing it. But going back to your definition,
Like,
So-
what are the other statements we can make about the layer X library? So it
Our layer-
introduces the
layer.
data type of a layer, and it introduces the data type of the data.
there are multiple shapes, no? If you are in the 1D domain, the interpolator, 1D domain, he has its own shapes because he defined a space with certain rules and what kind of objects are in that space, right? So
Yeah, but
every-
I'm using the singular to describe
that
the idea of a
the
shape,
the idea,
of which can be many,
Okay.
but we don't have to
so
talk about
the concepts,
facts.
not the
Yeah.
classes.
Yeah,
They are concepts.
the
The
idea
concepts.
of a layer and the idea of a shape, of which can be many implementations.
Shapes and shapes container. I would
Yeah,
say, you know, like an
Like
interpolator. What is an interpolator? That is not a shape. It's something that define a space for certain kind of shapes and knows how to deal with those, right?
Yeah,
So
shape container.
shaped space.
But how is it currently called?
There's no name for that.
Oh,
layer.
No.
Sorry, I was listening. Sorry. I was thinking about something else.
But no, but yes,
It is a layer.
it is a layer. It's just a layer. But has all this knowledge that knows how to deal with certain kind of shapes.
Layer of different types. Layer for 2D shapes, there are layers for 1D shapes.
No, what I mean is,
you say the interpolator itself is a layer again.
if we go here, this
Okay,
layer X,
get it.
let's go into the 1D domain.
Yeah.
In here, we have a specific interface, no, for the 1D K the layer. But then we have different categories, no? In each one of them, let's go into the interpolator 1D because this object introduce a set of shapes that we can use in that domain, and also itself knows how to deal with those shapes. But those shapes are really meaningful in this context, right? In the way, in the space, in the method that is implemented in the interpolator, in the way the interpolator deals with them, right?
Okay.
So if we go to the compositor 1D, there, well, now there's just one clip because I don't know where you could put also. Doesn't make sense to put a keyframe in a compositor. Maybe it does, I don't know, just for one frame it gets composed, but I don't know. But there is, the compositor just deals with this kind of shapes, right? Because this shape is different from the other one. This one has a stack index, for example, which is very specific of the nature of this shape and is necessary to embody into this context, which is the compositor, right?
Yeah.
So every one of these domains introduce his own, his own shapes and objects that he can deal with, right? Yeah. So
What are these other types? Launcher?
that just temporary stuff. Switcher, I don't know if there's anything here. Just take a spread of lay. I was start to implement this stuff, but in the end, what it does do is just take an index, select one of them, and sample it, and return it back. And it's a layer, so it's basically like a switch. But anyway, so I would say the key elements then are.
Should actually help to think like the compositor is a layer itself. Some sort.
The compositor, yeah, of course, because we still want to be able to plug it into something else, so we want to access it, no?
Yeah, but it's
Still,
at a hard time to.
every one of these operators, like interpolator, itself
It's
is a
another
layer, because when I sample it at the very end, this is the sample function, I sample it, and what it does, okay, I will interpolate between the, and between the shapes that I have, and so on and so on. But still, this guy is a layer. These two are not layer, but they point to layers. They don't need to be layers.
That I don't get. Why a keyframe points to a layer?
These are shapes, no?
These are
Yeah.
shapes.
They belong to layers, but
No. They are just shapes.
no, sorry, but you can put them in layers.
No,
You don't need. No.
The other way around.
What's their function?
Then I'm
Here,
lost.
look. We have a compositor that deals with 2D shapes.
Yeah.
And this is a shape.
Yeah.
The only function of this shape is to locate and shape something
It's an
into
empty
this
shell, and then you
into shell.
put a
Yes.
value inside.
It doesn't, don't put it inside. You simply just
Yeah,
say,
exactly.
okay, this is the layer that you will sample through this shape. Imagine that these shapes are like windows, no? Over
Yeah.
something else.
But then you can say that the compositor, in that case, it has shapes inside. It possesses those shapes. Those shapes belong to the compositor. Somehow, because you put those shapes in that compositor.
Yeah.
They
I mean,
belong to it.
we patch it like that.
Yeah,
No?
yeah.
We have a set of shapes that basically get passed to the compositor that has the shapes and can deal with them,
Yeah.
right?
Yeah.
and the output of the compositor again,
A layer.
It's a layer. The compositor is a layer.
yeah, can you go on the, here, if you have the
Well,
output? It's a layer, yeah.
It's a layer. Well, no, it's specific, but it's a layer. I can sample using a sample layer 2D, no? I provide a coordinate from my
Okay.
mouse and I can sample this space. And internally, obviously, we'll do his magic and just collect the shapes to the status manager is the guy that basically do a heap test basically over the shapes and takes just the meaningful ones, and then that's basically
If I get it correct,
One back,
you could say what the clip and the keyframe do, is they manifest the data into what so-called
into
shape.
context. Yeah.
So the layer can
And do something with
can
that.
do something.
Yeah.
But basically they make a manifestation of the data about.
These are
Body of
just
the data.
Yeah, exactly, yeah.
we describe ways on how to deal
Yeah.
with data, and the shapes is what we. The essence of a glass is that I can drink, but we gave it this shape so that it conforms to my hand and I can grasp it and I can hold it and drink. So we had to give it a shape so that we can interact with it.
And then you
Right.
put whatever you want inside.
It can be Coca-Cola, can be water, yeah, right? So, but still, this is the essence of this shape and how it embodies into this context, reachable to me, and I know I can sample the space with my hand and I can grasp it and do whatever I
We
want.
have a question in the chat. Does a shape have an alpha, and can it be a soft area? From Cat.
Yes.
I think
So it has alpha. Why? Because we can operate when we sample the shape. In reality, we are sampling the upstream thing, but we can also introduce some alpha functions, so modify what comes from below, and say, okay, I want to also multiply this alpha, for example, to what comes from the upstream. So yeah, it can have alpha, which means also they can have alpha functions. Let me just close this because I implemented that. If you carefully look at the shape of this, you see the circle has alpha. This circle has alpha. Where is it? Circle. Alpha. You see?
Yeah.
How? Well, inside the circle, what we do is, okay, this is sample layer T, which will be called when the compositor 2D wants to access the shape. And this shape, what it does, basically take the source, which is the upstream layer, and sample it. But instead of simply passing everything as it is, what it does, transforms the sampling position. And the way it does is like it takes the position of the circle and use it to offset the position of the sampling position, so that when we sample the circle and we sample here in the middle, the coordinate that will be passed will be 0, 0. It's just, imagine, like, it's easier to understand this at the 1D example. When we have a clip there, when we sample the clip, we enter into the clip, we want to start sampling from 0 there, right? Yeah. But this clip maybe is at position 5. So we need to offset the sampling position, right? And this is exactly what's happening there. No, if I enter the clip, you see, I'm sampling the layer which is connected from upstream, but still, yeah, I'm gonna mean bound transport function. Basically, I'm gonna transform the sampling position that comes from downstream as a request. I'm gonna transform it using the mean bound, basically. So I will offset as a default behavior. No, when I enter a clip, I will start from 0. But this is something that you can always modify. You can say, no, I just wanna pass through the sampling position that I received from downstream, and then it will just sample using the coordinates. It's something that you can provide. So going back to our example here of the circle, so we transform the coordinates so that we have how do you say, object space coordinate. We sample using object space, no? So yeah, like when I sample this rectangle, for example, the coordinate that I pass upstream is from -0.5 to 0.5, right? It's just like I'm entering into this other space, and I transform the coordinates. Instead of being in the screen position, they would be in quad position. Right? I can always transform it, but also I can operate on alpha, because also alpha get composed in the sense that there was a better example of that. Yeah, let me show you that. What is it? Open twice. Much stuff.
Nice tool, what is that?
French guy. Is it this one? Here you see better, no? This example in which we have one interpolator here, which itself is a layer that I can plug into another shape, and so on. No, so this is this track, so to say, that we create, where we have keyframe, clip, keyframe. Notice that I connect the same layer to 2 keyframes that will have the same values, no, right? To this keyframe and to this clip. Duration.
So a shape can contain a layer?
A shape points to a layer, no?
Okay.
Layer, of course. Yeah, because the shape is just some way to access the layer.
Wraps the layer.
Yeah, okay, sorry.
So, because when the shape get asked, okay, give me a value, it will just ask to the layer that you connect to.
Would it be a fair analogy to say that a layer is some sort of like, it's like a data source? If you think of a database or whatever, and then both shapes, interpolators, and compositors are like views on this data source or sources that then they can be used themselves as a new data source. Is that,
Yeah,
yeah,
I would say in my ignorance, I would say yes.
okay.
Hmm.
Uh,
Sorry, now I'm a bit confused.
think about the question.
If I go back to my trying to find the terms here, is layer X introduces the idea of layers and shapes. And even as classes, no, it has those as primitive data types, layers and shapes. And an interpolator is not really something that's a data type in the library, or is it?
Is it?
It's more like a thing that you built.
Yeah,
with
the
it.
library comes as a set of essential interfaces. And then with a node set, they already use those. No,
Yeah, but so the interpolator and the compositors, these are not core data types. These are
No.
things that are built.
that they introduce on top this notion of the shapes.
Wait,
Yes,
what
that's why,
the interpolator?
look,
Interpolator.
1D, the category is interpolator 1D.
Yeah,
This is something that you can build using these interfaces here. And you can say, okay, I want to operate into this space. And these are the shapes that I want to use in that space. And this is the way I want to operate with them. This is what you introduce, you patch on top.
even the shape you introduce, or
The shape is specific to that.
does it have a base data type that I know?
It's just an interface, just to be able to have multiple of them.
So this interface doesn't derive from a base.
No,
shape
no,
interface.
this is a completely independent thing that only the interpolator knows how to deal with. Because if you think about it, it's literally just a shape that makes sense only in this domain.
Yeah, it's domain specific.
It's just outside here, nobody even see those shapes, doesn't know how to what to do with those shapes. Only the interpolator knows that, okay, these are meaningful things to me because they are 1D.
So, but the interpolator is already kind of an application.
Yes, it is. It
It's
is.
one
It
application.
implements the basic interface
Yeah.
because it's something that still want to sample, and then he just accept his own private custom
Yeah.
shape.
And is it that the layer is actually the only base interface that the layer library
Yes,
provides?
yes.
It's the
Well,
only actual intrinsic thing it provides. And
Yes.
the rest is already implementations. on top.
Yes.
Okay.
so I layer is the only real common
Yeah.
thing,
Understand.
which comes with different aspects also, like the background. I didn't say.
Mhm.
It's small. Okay. Which comes with, okay, the notion that you can sample it, but also as a background. We can also go into a bit more details. Actually, I think we could wait for Sebastian. He couldn't, I think he could have enjoyed telling you about the background, because the way we implemented is already like an optimized thing. You could just pass a value, no, as a background if you want. But we are not passing a value, we are passing a function. And what happens under the hood is that when you have a compositor, for example, all the clips get basically wrapped into a function that you pass upstream. Because if you imagine, if you have, I don't know, thousands of clips on top of each other, and you just sample, if the first one is opaque, you don't need to sample anything, right? So it's like the entire background thing is a mechanism, advanced mechanism to build delegation, big functions, so that if necessary, if this is slightly transparent, or I sample what's below, and the same, if this one is opaque, then stop there. You don't need to do anything else. that's why it's a bit more advanced, the background topic. Regarding the alpha, going back to the alpha, let me show you here, like we have, can I play now? Yes. Alpha at that stage, then we have flip another alpha here. Okay, and we have alpha here as well, yes. So look, if I go to 0 here, how can I? Oh, well, let me just put this to 1. Okay. So if I go to 0 with alpha, you see that this influences both this keyframe and this clip, no? Because they both point to the same layer, right? And keep in mind that this is a 0. The value is 0 because the background here, actually, yeah, it goes to -1. So if I do this, so yeah, the background is 0.2. Sorry, 0.5, let's say. Then, obviously, these keyframe and clips will be transparent, and so the background will just come up. No, as a. So if I go to alpha 1, then let me just put a nice alpha there. If I go to alpha 1, then you see that we have the value there, right? And I interpolate from there to the background, which is 0.5, right? This is what should happen. So, but let's say this is alpha 1 now. If I touch this alpha here, obviously we expect something that doesn't happen now.
Yeah, we expect the LFO to disappear on the clip and just show the background.
Normal blend. Why is why is that?
But wait, the clip is not overlapping, no?
It's not about overlapping, it's about transparency.
Yeah, but you're sampling at a specific. No, you're sampling the whole.
Look, maybe it's easier to look this other scenario. So let's say that we have red background, no? If transparency here, if alpha is 0, then you will have the background coming up here and here, no? Right?
Yeah.
No. I need to check why it doesn't work. This one should work. It was working, but I changed something still to fix. But as you notice, this so this is the background, okay? Because we are using this into this clip here, which is duration. I need to check.
What would we expect to see if the middle alpha, these guys were working?
We would see that only the first one is influenced by this, right? And this other one just is alpha 1, so it just simply takes that one. I can operate with alpha at any level, no? Right? It was working. I probably changed something. Now I need to go through these patches again. But just to say that this is just alpha. You can define not only the alpha value, but also the technique. You can, by default, usually you multiply alpha, right? But you might want to add with the alpha that comes from downstream. So you can have very complex alpha behaviors, right? And so, but the general thing is that you can always, with alpha, you basically go to transparent objects. So the background, whatever it is underneath, just gets in. So yeah, write down the need to check this patch and fix them, the alpha part. It should be a very stupid thing.
If you go back out in here. So we have identified that the first 4 boxes here are like super core to the library,
Yeah, together with the domain-specific implementation of those, like,
but these are
yeah, you see,
domain specific, okay,
these
yeah,
are just more specific.
yeah.
Yeah,
But then the 1D and 2D categories are like, yeah, they're already using.
Applications of these.
this is the most generic as
Yeah,
2 types, as the value type and the domain type. They are open, right? Because we don't know the domain, the dimensionality of the sampling position, and obviously we don't know the T that can be anywhere. So if we go into a 1D domain, for example, it's already more specific because the type, the value itself can be everything, but we know that the dimensionality of the sampling is defined.
yes.
So it just specifies a bit more that. And same is for the 2D.
Yeah,
Just a vector. And so, yeah, we can see, and then you see also here the compositor, which is part of this domain, compositor 2D, just implements, has his own way of having shapes which are very specific to this object, and he knows how to deal with these shapes and whatever, and and just compose them using some very deep, simple elements from the other library. And itself is a layer so that I can still sample it.
At some point, we will need more domains or whatever we want to call these things. Is this made in such a way that I can do that as a user in my own patch, or would it be somebody modifying via layers? If I wanted to introduce the 3D stuff, for
You
example,
can do whatever you want.
but
you
can I do it outside of here? Or does it need to
course.
happen here?
Of course, because obviously all the objects that will operate with that 3D domain that you register will need to know about it. Right? But I mean, you can always like define a 3D compositor and then define ways to translate from a 2D space or 1D space to your specific 3D space, no? And that's something that easily you can do. We saw how to transport. But yeah, you can do it because the most essential interface is layer interface here that you can always implement, no? And then specify. You will have your own interface probably in there, which is I layer my own 3D space, which say, okay, my sampling domain is this kind of type, no, or this. So you can always extend there. But I would say together we should just implement stuff here and extend here, provide some other things, but meaningfully, I mean, they should be part of the library. Yeah. So tell me now, how beautiful is this?
Very, very special.
So, is it clear now
Yes.
the shape?
Yeah, I was just confused because I thought there was another distinction with like pure value. And then you put the value inside a shape and the shapes inside a layer. I thought that was the reasoning.
Okay, is somewhere else, no?
Yeah.
Yeah. This library just deals with layers, so to say. The
Yeah.
values themselves are just VL values, right?
Yeah,
So,
sure.
just a way to adding the shapes. It's a way a layer can embody into a very specific context.
So can you scroll down a bit after after interpolate 1D? Get a spread of layer. Yeah. So you could directly connect the value layer 1D directly to the comps and then to the interpolator, for instance. You can do that.
To connect what?
Like the
This
the
one?
value- No, the value layer 1D, one of those, you could connect that, yeah.
Yeah,
That was-
of course,
yeah,
it's a
okay.
layer.
Everything, yeah, layer. I thought there was an extra notion of
No.
value, and that's it.
We just deal with layers, and this is a layer that inside, when we sample it, then it has its own private space.
Yeah.
It's like a child, there's no private thing that plays with things. And then access externally to the layers,
Okay,
but it's private, the space, no?
So this example already shows a rather complex example of nesting things. It's not the
Nice.
simplest thing
No,
you
no,
can
no.
do with it. It's nested.
Yeah,
And here, every input and output is a layer, yeah? Like the output
this
type,
one, yes,
okay.
But that should be like.
the shapes are not layers though, because
It's confusing.
it doesn't make
Those
sense
types.
that you can sample a shape like that.
If you see the concrete type and not just its layer.
Yeah, but you know, that's how,
Yeah, I know, but it would be, I guess it would make sense if you, it would be easier to understand
Well,
from you that they all output
This one
layer.
accepts a I layer 1D.
Yeah, but like the keyframe.
I know
No,
that,
yeah,
yeah, that's something that,
yeah, I know, but
yeah, I think.
it should be, yeah, but you cannot say the. You cannot write the.
I will need
description
to
for the
wrap
output.
this into another node and expose
Yeah,
the
yeah.
pin and type the pin.
Exactly, yeah.
No. Unnecessary.
Yeah, okay, you just have to know it.
Well, but still, if you highlight here, you
Mm.
see where you can connect, You see that these are, okay, these are layers.
Yep.
If I take,
it's kind of a general
Mhm.
issue. No? It's
yeah,
not
if I take
Yeah,
a value layer 2D, which is something that I can send to 2D. Obviously, I can't connect it here because it's a 2D layer,
you know,
right?
Yeah.
What would you expect? You can have multiple interfaces.
Yeah.
There isn't one. It's not a.
Whoa, it's late.
Yeah.
Hey, mate.
So we'll stop the recording for now and we'll be back this afternoon.
Yeah,
How long is the break for?
2 hours, you said, no?
yeah, it was.
But now we've already-
at 2.
Yeah.
Yeah, we
Back at 2.
back at 2. Great. Thanks for watching.
It's a bit.
Yeah, it's too short, because it's already 1:20.
Oh, back at.
No, at 3, sorry, it's
Back
a
at
3,
three.
it's a 3,
Back at
3.
3.
From 3 to 6,
Okay.
that's the session, the other session.
Bye.
Bye.